relate to that. I have done many things and I've learned not to do those things ever again. All right, guys. So let's transition away from coffee. And does anyone have any questions from homework? I'm sorry I had to miss St. Patty's Day. Did anyone else wear green? I was wearing green. Very few people do that anymore, apparently. I don't know. But, oh, is anything from homework? You guys good in homework? Okay, all right.
I had an issue with homework.
Yes.
I'll have to find it.
While she's looking for that, do you guys remember what's happening a week from today?
Midterms?
Midterm. So over the weekend, I'll post a practice midterm, and then I'll have most likely a video of solutions for it. So we'll have that as a study aid. What's going to be on the midterm is everything since the first day. Sounds exciting.
I had issues with 2-6 number 1.
2/6 number what?
Number 1.
1. Okay. All right. Oh, okay, good. So I've been waiting for questions from this section because this section can get a little interesting. I think I warned you about that. So here's the problem with this. What measurements do they give us that we need to figure out the volume?
So they give you feet and inches.
Okay, good. So I need the length, the width, and the height, which is how thick it is. So it's, yeah. So beautiful. So my next question was going to be, what's wrong with that? Like you said, it's parts in feet and parts in inches. Now they need me to have the answer in cubic feet. So which unit obviously is wrong?
The inches.
Yes. And what sucks about converting 4 inches to feet is that 4 inches is not even a full foot, right? So 4 inches is how many feet?
It's 1/3 of a foot.
Good. All right, right? Because a full foot is 12, so 4 is 1/3 of that. So then you get your 1/3 of a foot, and then all you have to do is multiply all this shit out, right? So how many cubic feet? It would be 14 times 16 times 1/3. And you collect all your feet together, it's cubic feet. Is that okay?
Okay. Yes.
Yeah, so you're on the right track. You got it.
All right. Thank you.
Sure. You probably just helped out everybody else, which is good. So that's how you get this thing started. Now, number 2 deals with that idea we talked about. If I have cubic units, how do I convert to other cubic units? So we discussed that before. So I'll wait until I get a question on that if you're not having a good time doing that problem. Anything else, guys, from homework? A few more people just came in. Okay. I'm always hopeful. All right. If there's no other questions, we're just going to move right into the next section. All right, let's do it. So I think I told you guys 2.7 is not currently on our homework list, right? But I'm still going to talk about it, and I'm going to make it extra credit. I want to talk about it because most of you, I think, are going to take statistics next. Some of you guys might take 120, but either way, you want to kind of know this idea. And let me talk about it in general. Oh, let me make it all about me too. Let's see. There we go. It's all about me. Hopefully, you guys understand. I'm joking when I do it. So let me ask you this. Let's see. Yeah, so um, everybody knows about a certain website called Rate My Professors. Do you guys know about that website?
I've
Okay.
heard of it.
You've heard of it? I remember a long time ago when I was on the East Coast and we learned about it. The professors didn't even know it existed. So we all kind of learned about it. And the next day, you could tell the professors had gone in and rated themselves. It was just so obvious. It was kind of funny. Anyway, there's another website that actually says nothing about opinions about the professors. It just gives you the grade distributions for each professor. Are you understanding what I'm saying? So this professor gives this percentage of Fs and this percentage of Ds and so forth. Do you guys understand what I'm saying?
Yeah, so you're more inclined to take a professor that has a high percentage of A's, right?
Maybe. Depending on your perspective, I would hazard a guess that a lot of students would feel that way. But thankfully, some students want to be challenged. But yeah, unfortunately, a lot of us go for the easy A's. And unfortunately, there are professors that give fill in the blank tests that I've personally seen and made me throw up a little bit. But anyway, so if you knew, stay with me. If you knew the average grade, so let's say you've narrowed it down to these two professors, and they have like the exact same Rate My Professor score in comments. You guys with me? So there's nothing that different between the two of them. And you know that they both give you an average of a C. Let me see. Let me turn off my Mars. Let me write some stuff down on the board. No, not blobfish. Go away, blobfish. Okay. All right. Did you do it? Let's see how lazy I can be. All right. So let's say you know they both. So here's Fred and Ethel, and they both give an average of a C, right? That does not help you figure out who to take. Oh, and by the way, is everybody with me so far? We haven't done much of anything, but just keep going with me. Yes, exactly. Thank you. Somebody got that. Where was I? Shit. So they both give exactly a C, and they're the same on Rate My Professor. That's not good enough to determine who to take. I want just a little bit more information. Also, we're at university. We're not at community college. What's the difference in grades between community college and university? What's passing at Grossmont? What grade?
Is it a D? Is D passing?
Well, all right, let me say it like this. What transfers? C. You guys understand? A C
Yeah.
is basically the floor for what you want here. But what is a passing grade at university? Anybody? Now you can say what you just said.
It's a D?
D.
Oh, I thought it would be higher. Okay. my
No,
bad.
dude, it's crazy. Now, of course, I don't. Anyway, we can get into a lot of the idea behind it, but oh well, it's the way things are. Just don't think about that next time you're driving across a bridge and you're like, did my engineer, is he a B guy or a D minus guy? Anyway, so sorry. You're at university, so a D is passing, right? You could actually just keep going after you get a D. So one professor, you find out something more. So I know where the middle of the grades are basically for both. I know the average grade, but there's another thing that if I knew it, I could determine better. And that thing is how spread out the grades are. So let's say that Fred gives everywhere from an F to an A. So his spread is bigger. And Ethel gives from a D to a B. So her spread is smaller. All right. Hopefully you guys get my scale low to high. Which one would you take? And this is sort of like what Tristan was saying earlier, but there's a little bit extra consideration here. Which professor would you take? Is
The
there
one with the more consistent grade point average, right?
all right, maybe. Are grades dependent solely on the teacher, or should they be? Does that make sense? All right, let me help you out a little bit. Which teacher would you take if you knew you were gonna suck in that class? If you just knew that class is gonna kick your ass, which teacher would you take?
The D professor, right? Because they all get Ds, consistently get Ds.
Well, suck. Okay. Does that make sense? Because then you're basically guaranteed to at least not fail, right? Now, which teacher would you take if you knew you were going to kick that class's ass? Somebody else tell me. I mean,
Everyone,
yeah, why?
because like it has better grade consistencies instead of the other one.
Well, let's tell me again, which one is your pick? Fred or Ethel?
Fred.
Fred. Now, what do you mean Fred has more consistency? I don't understand that.
Well, because the other Ethel, like, you know, if you're gonna suck and if the all I don't know how to put it into words.
So he gives grades based more on your performance? Is that what
I
you mean?
guess so.
It looks like maybe he does, but we don't know.
That's true.
But that's still a good point. I like it. So the reason you would take Fred is if you know you're going to kick that class's ass, why would you take the person that seems to only go up to a B? Right?
That's true.
And Jeff is talking from experience here. I kicked this class's ass and the teacher gave me a B because he's waiting for a freaking deity to take his class. Anyway,
Yeah.
I might still be a little upset about that. I'll never forget going to his office door, looking at my grading, going, "What the shit?" Anyway,
I'm glad that's never happened to me.
yeah, just wait. All right. Sorry, something to look forward to. Anyway, does everybody understand? So there's kind of a larger point here about you actually can get access to grade distributions for teachers. It's public domain knowledge. You could actually call Grossmont and request it. Oh shit, did I just tell you? To get on the website, it costs money. This website, there is a website that gives you grade distributions. I haven't looked at it in forever, but oh well. Okay, now, the more immediate point, the more general point is this idea of we can calculate the average for a set of data. We know how to calculate the average. You guys with me? We've done it before. Something else that is almost equally important to know is how spread out the data is. So there's an actual number that we can calculate that gives me an idea of how spread out the data is. So let me ask you this. If I gave a test and so if I gave a test in two different classes, class A and class B. Now it makes it sound like, I don't know. Let's call them stats and calculus. Sorry. And in stats class, the average was 74. Same thing in the calculus class. But in this one, the spread, Jeff, really? The spread, I'm just going to give you a number, and let's say the spread number is 12, and in this one, the spread number is 2. So what that would mean, stay with me now. This is what I would expect. This is a normal kind of spread number. This tells me that there were people that did kind of poorly, right? So, all right, stay with me. The spread number is the measure of how far away the data points get from the mean on average. Let me say that again. I really want you guys with me. Remember, this homework is extra credit. Please still listen, but understand you just have to kind of listen and let it come in. You don't have to be like so. All right. The spread number is the measure of the average distance that the data points get away from the mean. Does that makes sense, what I just said.
Could you explain that with the bell curve? Because I understand like the middle of the bell curve is basically the mean. That's where all the averages line up.
Not
However,
everything is bell curve shaped.
I understand,
Okay.
but like,
yeah.
if we looked at it like it's a bell curve,
Sure. If we looked at it like it's a bell curve, this one would be fatter and this one would be really skinny. Because this one, more the data gets further away, and this one, the data does not get very far away from the mean at all. So on that picture I just drew, the height tells me how many data points are there. So this stays kind of high all the way over. And that's explaining that more data gets further away from the mean. Here, the data points only get on average 2 away from the mean. So like 72 up to 76 is where a decent percentage of the data is.
okay.
So I don't want to get too technical with this, and we don't have to. The spread number just tells me, on average, how far away do the data points get? That's all the spread number tells me, right? So the average tells me kind of what's the middle of the data. And the spread just tells me how far away does the data get away from that middle. Okay, I love it. You guys are all like, dude, I cannot drink enough coffee to stay with you, but that's all right. Just trying to stay with you.
I understand.
Okay. So the next level of this then, if we understand that I want the spread number to tell me the average distance from the mean to all the data points, and that makes sense, that would be like a spread. How the shit do we calculate that for a given set of data? So the next level, of course, would be, what's the math behind calculating this thing? So let me ask you this. Don't worry, we're going to do some concrete stuff in a minute. Just how do you find the average anything? So if I wanted to find the average age in this class, I have to first get a list of what?
Ages.
Ages. Does that make sense? If I want to find the average weight of soup in the supermarket, what do I first have to get a list of?
The weights.
The weights of the soups, right? All right, y'all, I think y'all see so if I want to find the average distance from the mean to the data points, the average distance from the mean, the average to all the data points, what do I first have to get a list of? So I don't find, let me say this a different way.
All the distances, right?
Yeah, I need a list of how far every data point is from the middle, right? Doesn't that make sense? If I want to find the average age, I need a list of ages. If I want to find the average weight of cats, I need a list of weights of cats. If I want to find the average distance to the data points from the middle, I need a list of distances every data point is from the middle, because then I can add them up and divide by how many there are. Okay, I love it. You guys just stay with me. Stay with me. I really obviously want this to make sense. To find the average anything, I just need a list of those things, and I can add them up and divide by how many there are. Okay, so let's do a very simple set of data. Maybe I'll even get up off my ass. There we go. I will. Here we go. All right. Oh, it's a special occasion. All right. No. All right. So let's take some data. I'm going to list it like this. I'm just going to list some data here. Right. So let's say I have, what you got, Jeff? I don't know. 5, 7, 10. Let me make it decent. 22, and then I can do 10. Sure, another 10. I like it. All right. Could somebody help me out just figure out what the average is of the data. What's the average?
26.75.
Whoa, what?
Oh, wait. I think I found the other one.
8.
8.
There we go. Yeah, so how do I find the average? I add them all up. So then the average is 32 divided by 4 is 8. Cool. Now, how do I find how far away each data point is from that average? What operation is that to figure out how far apart two numbers are? What operation do I do? Subtraction. It's crazy. So I'm going to do x minus the average to figure out how far away these are. I'll even see who's below average, who's above average, because the below average ones will be negative. Is everybody with me? All right, so now what's 5 minus 8?
-3.
-3.
7 minus 8.
-2. 7 minus 8. Oh, my bad. 1. Sorry.
10 minus 8.
3 or 2. Sorry.
That's all right.
I'm really out of it today. It looks like.
I still appreciate you're trying. I love it. Get some more of that coffee. There you go. Get it in there. Terrible. I'm a caffeine pusher. All right. Now notice something. What happens now? What am I supposed to do now? I've got a list of the distances, right? What did we say we were going to do to figure out the average distance? We have to, how do I find the average anything? I would do what? How do I find the average anything?
Add them all up and
Add them
divide
all
by
up.
the number of
And
them.
divided by the number.
What do you get when you add those up? What do you get when you add those up?
0.
Holy shit. Would you guys, do you think that there's zero spread here? Are the numbers not spread out at all?
Or is there just not enough numbers to cause
No, no,
spread?
No. The only way to get zero spread is if my data was this, maybe. They have to be the exact same number because then that would be zero spread. No number gets away from its mean at all. I really want you guys with me. So of course, do you guys notice the problem here is that some of the answers are negative. Some of them are positive. So this will always add up to be 0. So you can go, oh, thanks, Jeff. Good job, buddy. You have led us to this dead end. Thank you, Jeff. All right, now, so here's what we do. We could take an absolute value, and there are issues with that, right? If I take an absolute value, I make the numbers positive, but the absolute value is actually kind of a gross thing graphically. It's got a hard turn, and there's a lot of issues with it. What's something else I can do to make something always come out positive? What can I do to a number to make it come out positive?
Absolute value.
No, I just said that's bad.
Oh,
right?
my bad. Sorry.
There are problems with the absolute value. One of them being like the absolute value. Do you guys know if I graph it, it looks like a V? I don't know if you guys know that. Do you want to be in a plane that does this? Hello, I'm your captain. Everybody, and you're dead. All of you are dead. So let's not get on that plane. What's something else I could do to make something always positive?
You can multiply it,
By,
a negative.
but then these would be negative.
Oh, you're right.
What's something I could do to always make the answer positive besides absolute value?
I forgot the name for it when we put the 2 lines.
Oh, that's absolute value. I already said there's a problem with it, so we have to try something else. All right, so let me just tell you guys, you're going to kick yourself. Just square them, right? Just square them. What do you get when you square everything here? What's -3 squared?
9.
+9. What's -1 squared? Thank you. 1.
1.
Now, what does this mean? Real quick, real quick. Stay with me, stay with me. I square to kill the negatives. What do I have to do at the very end then? If I'm squaring everything right now, at the end, I'm going to have to take
A square.
square root.
The square root.
I know. All right. Stay with me. Stay with me. There's some, I really want you to understand, there's some mathematical problems with absolute value. It's got some issues. So I can't use absolute value. So the next immediate simple thing I can do is square, which means I just have to square root at the end. So how do I find the average of these?
Added them together. It's
Okay.
18.
Say again?
You want to add the total? 18?
Sure. Yeah.
It's
18.
Uh-huh.
Four.
Divided by 4, I like it. So the spread squared is 9/2. It's going to be 4.5. Is that okay? If you got 18 divided by 4, it's 4.5. You guys with me? So what's the spread then? I have to take the what to kill this? Square root. What's the square root of 4.5? Somebody help me out. It's like 2.12. I don't know. Is it really? What is it?
Yeah, that was a 2.121.
Holy shit. Now watch, now real quick. All right. Here's the average. The average was 8, right? Watch. Isn't 5 3 away from 8, and 7 is 1 away from 8, 10 is 2 away from 8, 10. I mean, we can see them all right here. So the average distance being 2.1 makes some sense. On average, the data points get about 2.1 away from the mean. So let me ask you this. We'll do one more problem and then won't say any more in this section until somebody asks. Because again, this is going to be extra credit. Do you think that if I had this data instead, all right, Jeff, you could do it. Let me hold on. Give me a second. All right, I could do it. I could do this. I could do this. You sound so certain of yourself. Give me a second here. 6, 11, and that would be 12. Okay, I did it. Yay. All right. What the hell am I trying to do? Can somebody do the, what's the average of these data points? What's the average of these?
8.
8. I love it because they add up to be 32. And then divide by 8. Jeff, you could do it. Divide by 4, you get it. All right, now, stay with the same. So they have the same average, just like Fred and Ethel, the teachers have the same average. But which set of data is more spread out?
This new set of data.
The new set of data is more spread out, right? More of them get away from 8. Okay, so let's calculate. So the spread for this data, the spread was 2.12. Jeff, you can do it. 2.121. So we're predicting. So I'm going to erase this. Here we go. You ready? I'm going to erase all this business. Go away. Go away. Go away. Go away. All right. So let me put this data here. So we're predicting that this should be a bigger number. So 3 minus 8, -5. 6 minus 8, -2. 11 minus 8 is 3. 12 minus 8 is 4. Then I square each one. All right, let me stop for a minute. I'm going a little fast. So I have a new set of data. I find each data point minus the mean, minus the average. I don't know. I keep saying mean because the official name for average in statistics is called the mean. I can't remember if this book tells you that. So 3 minus 8, 6 minus 8, 11 minus 8, 12 minus 8. Then I square to kill the negatives. Bam, 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 bam. Then I want to find the average squared distance, and that's why I have to square root at the end. So to find the average square distance, I'll just add these up, right? When I add those up, what do you get, Jeff? You get 54 divided by 4. Is that 13? 13.5?
13.5.
Cool, I like it. And then you take the square root of that, which is, I don't know, 3 point, you don't know, Jeff. I don't. 3.4. 1.2, 1.2. No. 3.67. 3.67 roughly. So it's obviously more spread out. So you can imagine. Now, this is a very small set of data, very small set of data. So I can kind of tell just by looking at it that this is more spread out than that. And that's how I got you guys to estimate that this should be more than this. But for a really huge set of data, if I just give you the mean and the spread, I almost don't have to show you the whole list of data. You sort of have an idea of what it looks like. So that's why it's important. If I just know the middle, if I know the middle is 8 and I know the spread is 3.67, then I know that the data points get about this far away from this. I have an idea of what that looks like. So if I give a test, all right, I'm going to erase this. So yeah, let me erase this over here. Are you guys ready for me to erase this table here? Can I do that? All right, I'm going to do it. If I gave a test and I get an average of a 75 and a spread of like 13, that's normal. This is normal. If I give a test and I get an average of 75 and I get a spread of 20, let me see what you guys think. What do you think that tells me? Think about it for a minute. What most likely happened here that makes me concerned? I mean, the average is the same. But here, the data points are more spread out. So what do you think would cause that to happen? What would make the data more spread out with grades on a test? That would make me worried.
Some people scoring really high and some people scoring really low.
Low, more likely. Because there's more room below 75 than above 75. So more than likely, like a few people maybe got into 20s, or maybe a lot of people got into 40s, right? And then I'm like, oh shit, what happened to these people? Here, I could still have a few that did really bad, but not as many.
How would you know that they're not outliers and they
Well, that's
are?
the thing. That's the thing. They would be, all right. I love this. The outlier for this data would not be nearly as low as the outlier for this data. Being outliers doesn't mean you're not legitimate,
Okay.
right? It could mean that it was a mistake that somebody got an 84 and I wrote a 48. That could mean a mistake, but it doesn't mean that it's automatically not legitimate. Yeah. All right. I went a little further than I needed to, but that's me. So now, I mean, that section is extra credit. The way I treat homework extra credit is I add it on top of your homework grade. So you could actually end up with a higher than 100 homework grade if you do all the homework and the extra credit. So I'll add a place to turn that in on Canvas. You can still ask questions from this section if you want to give it a try, right?
Okay. So now I want to talk a little bit about section 2.8, which I think I actually have homework for. Oh, yeah, let me see. Where am I? I'm so down here. I need a booster seat. Booster seat. All right. Let's take a look here. My mouse went to sleep. There we go. Let's take a look at the homework real quick. Come here. Okay. Ow. Give me just a minute. Make sure I actually put, yes, thank God. Okay. So the book, if you look at section 2.7, if you want to try the homework out, they kind of do the same thing I did. I just put the letter X instead of the word score, right? So you can look at the examples they do. They do the same thing. They tell you how to do it in the calculator, but oh well. They do talk about this, the normal distribution. Somebody was asking about that. I'm not going to go too deep into this, but here's something interesting. All right, this is getting very technical with the letters. So one of the first things I do if you take statistics with me is I give you the Greek alphabet. You don't have to memorize the Greek alphabet. I just do it because there's a lot of Greek letters in statistics. We just like to use Greek letters for our variables. Why? I don't know. But what this basically means is this is one this is one spread number up and this is one spread number down. So I went one step away from the mean basically. And 68% of the data is in there. That makes sense because the spread number tells me how far away the data gets on average. So there should be a decent chunk in there. Okay. Oreos. No, why did I have to see a picture of Oreos? Go away. Evil. All right, so here's what we're going to talk about in section 2.8. Let me get away from that. Let me give you an example that you guys have seen before. Have you ever taken a class? Well, yes, you are currently taking a class like this, where the tests and the quizzes and the homework and all that count for different percentages of your overall grade, right? You with me? So like if I take a look at my syllabus, let's see, where's the syllabus? There we go. Hopefully this is not the first time you guys are seeing the syllabus. But right here, I tell you how I calculate grades. How does that work practically? How would you calculate your average if you knew all these grades? How would you calculate your average? I don't know. Let's figure it out. And plus I have the extra thing about the percentages. So let me just give us an example with set percentages. Okay. So. If I had a class where work with me. Okay. If I had a class where the test average was 35%, homework was 10%, and the final would be, ooh, that's a big chunk. Let's say the final is 30%. So what's that leave? 75%. And then there's like a, sure, group work and other stuff would be 40, 70, 25%. Sure. All right. Just say we have a class like this. Is my room tilted? A little bit. All right, work with me. Technology, okay. Everybody with me? So this is basically like a little bit different class than ours, just to make it more set. And let's say that you know that your test average, let's say your test average is 81. Let's say your homework is 94. Let's say your final exam, it was a rough day and you got a 73. And let's say your group work and other stuff is 85. What the hell is your average? What the hell does that mean? What's your average? Do I just do I add these up and divide by 4?
Yes.
Uh-oh.
No.
So then you're telling me these don't mean shit? Which one of these is going to count the least?
Your homework.
Homework. Homework's going to count the least, at least for me, right? Because that's the way it's supposed to be. In a perfect world, I'd make it worth 0, but we're not in a perfect world. Now, so what the shit? How do I marry these two things together? Obviously, I cannot just add them up and divide by 4 because the 94 should count for less. For what percentage should it count? 10%. So what percentage of my final grade is made up by this test average?
35%.
35%. So if I take 35% of 81 and I add 10%, no, Jeff, you're getting ahead of yourself. 10% of 94 and I add 30% of 73 and I add 25% of 85, right? So I do this, I multiply the weight. These are looked at as weights. So the heaviest weighted thing is the test average and the lightest thing is the homework, right? So I multiply the weight by the grade, weight times the grade, weight times the grade. So let's try it. So in the calculator, you would do 0.35 times 81 plus 0.1 times 94 plus 0.3 times 25 times 85. $42, $22.64, 74. 28.74. That can't be right. Stop trying to do it in your head, Jeff. Can anybody help me out with that? Oh, you got it. 80.9. Okay. So like an 81 average. I like it. That's how you do any class like mine, where I give you percentages for each of your things. All right. So what I'm going to try to do is to try to show you the math behind why this works, because I get the feeling not all of you trust this. You trust it to the point where you're like, all right, you're the math boy here. I guess you know what you're talking about. But I kind of want to show you a concrete example of why this works. Why would I multiply this times this and so forth? Okay. So let me do that. And then we'll end early today. Why not? Okay. So I'm going to take this away. Everybody ready? Oh, real quick. What do you get if you do the wrong thing? If you do this wrong, what do you get if you just add these up and divide by 4? Can somebody help me out? Those up, divide by 4. Anybody? You guys out there? Help me. 175, 248, 48, 333 divided by 4 is 8.
83.25.
Yeah, there we go. I was getting there. 83.25. Why is the actual average lower than just adding these up and divided by 4?
Oh,
Because of homework.
Yes, homework was the highest grade, but it was weighted the least. So your actual average is going to count that less than you do if you just treat them all equally, right? Okay, so you got to be really careful. Don't do this and then the teacher tells you, oh, your grade is this, and you're like, wait a minute, what the shit? No, you just calculated it wrong. Stop doing that. Okay. So let me give you a concrete example of what the hell's going on. All right. So watch this. Let me see. You can do it, Jeff. What do you got? What do you got, buddy? Write something down. Okay. Let's make it smaller numbers. Okay. 1, 1, 2, 2, 2, 3, 3, 3, 3, 4. Okay. There should be 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did it. How would you calculate the average?
add them all up and divide by 10.
Holy shit. Yes, and let me do that in a kind of a smart way. There's 2 1s, there's 3 2s, there's 4 3s, and there's 1 4. Is that cool? Right?
Yes.
Okay, and then divide it by 10 because there's 10 numbers. I like it. So if you do that, you get 6, 8, 24. I get 2.4. Is that what you guys get? If you do that? 16, 22, 24. I don't trust myself today, but yeah, okay. All right, that's amazing. Sorry. Thanks for showing us that, Jeff. Now watch. That's nice, but I can't do that if I don't actually have a list of data. So watch what I can do. Watch what I can do. Can't I do 2 tenths times 1 instead? 2 tenths times 1 plus 3 tenths times 2. 4 tenths times 3. 1 tenth times 4. Now, would you ever actually do that with a list of data like this? The right answer is hell no, Jeff. Why the shit would I do that? Right? Now, but again, I'm trying to make the connection with the problem we just did, and that was based on percentages, correct? Isn't 2 tenths 20%? Times is of 1 plus 30% of 2 plus 40% of 3. Jeff, you can do it. We're changing it to more English. There you go, buddy. 10% of 4. I don't know if you guys are with me. Do you guys see that? Do you guys see that? So this is like saying the 1s are weighted by 20% because 20% of the data was 1s. The 2s are weighted by 30% because 30% was 2s. Blah, 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 blah. So these are the weights. These are the weights, and these are the values. And we're doing exactly like what we did. We multiply the weight times the value and add them all up. That's how we get the freaking average. Let's see. Does this work? 0.2 times 1 plus 0.3 times 2, 0.4 times 3, 0.1 times 4. Is that cool? Just changing those to decimals, right? So I get 0.2 plus 0.6 plus 1.2 plus 0.4. And that is 82.4. Same answer, of course, right? Now again, I would never do this shit if I had a list. Of course, I would just do this. But this is the connection between what if I'm not given a list? What if I'm giving percentages and numbers? Percentages and numbers. I don't have a list. Oh, I could just do this. Okay, now I lied earlier. We are going to do one more thing. I'm so evil, but you should know. You should know. I'm going to do one example of what this would look like, and then we'll call it a day. I'm still going to let us out early. Don't freak out. So I'm going to erase all this. You guys ready? You guys ready? Okay. You know what's interesting? Anyway, I've never quite taught it this way. And I like this way, so I'm going to start teaching it this way. Okay. So the way we're going to see it is a little more like the way I showed it in the last section. We're going to get data that looks like this. Next to this, I'm going to put a P of X for percentage. And to be really honest, it could also stand for probability. But this is the percentages. This is like the weights. So if I put like 0.5, 0.3, let's make it a little more interesting, Jeff. Ooh, this is going to be so interesting. Look at how interesting that is, Jeff. All right. What's got to be true about these? What's got to be true about these percentages? Why did I have to be careful when I got to here? Anybody? What's true when you add them all up? What does it have to be?
Uno.
1, yeah. It has to equal 1, right? When you add them all up. Because of course it does. These are all the percentages. They have to add up to be 1. So what does this look like in this table form while I do data times weight? 1 times 0.5. So I actually do this. Let me see if you guys are cool with this. I do all the X's times all the probabilities. So that's what that looks like as a header. 1 times 0.5 is 0.5. This is exactly what we did earlier, right? Just in a more table form. 2 times 0.3, 0.6. 3 times 0.15, 0.45. 4 times 0.05 is no, Jeff. Get out of there with that shit, 2. And whatever the hell that is that 1.75 maybe?
Yes.
Yes. Now, what's the average of just what do you get when you average 1, 2, 3, 4? What's the average of just 1, 2, 3, 4? Forget all the other shit. What's the average of these things?
1.
Sorry?
1.
No.
The average.
The average, yeah.
2.5.
Yes, doesn't make sense. Right in the middle. That's the average of the data points. Stay with me now. Stay with me now. Why does it make sense that the actual average is less than this? That's not the right average. Think about the weights. What's the heaviest weighted data point? What's the heaviest weighted number?
1.
1 is the heaviest weighted. All right, sorry. I won't sing anymore. I'm sorry. Everybody hated that. So the mean, I really want this to make sense. I love that we call these weights because this is the heaviest weighted thing. It's going to pull the mean closer to itself. 50% of my data was 1s. Of course, the average is going to be less than what it would have been. Okay, I threw a lot at you today. So, I mean, this is the way. This is a really good way to set this up because you can multiply across, add down, and that is your average. Let me make that really clear. Shabow. So that's how you would do, you would put your grades, you would put the weights, multiply across, add down. You can figure out your average. Kabam. All right, that's enough. That is enough. We'll obviously do more of that next time. We'll talk about homework stuff. Let me know if you need to hang out, if you have any questions. Otherwise, you are free. You are free.
All right. Have a good weekend,
Thank you.
Professor.
Thank you.
Professor, I have a question.
Yes.
So one more time, I know you told us, one more time, can you tell us what can we do about the extra credit, about extra points, extra
Just
credit?
do the assignment in section 2.7, and I'm going to create a place for you to turn it in. And you actually have until the day of the final to turn it in for extra credit. Yeah.
Okay, thank you so much.
So it'll show up in the modules. You just have to make a place for you to turn it in. Yeah.
Thank you, Professor.
You're welcome.
Bye.
Thank you.
You're welcome.
How long do we have to do homework corrections?
Till the day. Same thing for quiz corrections. Everybody else okay? You guys good? Okay, I'm gonna get out. Bye, everybody.